in the week 4 folder, go to Forces and Motion PhET Part 1. Okay, so here are the instructions. Go to this PhET simulation. There's a link if you need it. Start with this net force section. All right, and complete the simulation assignment. Anything you not finish in class will be homework. And if you need to re-see this or revisit anything that I say, feel free to go to the YouTube channel after class and check out what's going on. So click on My Document. Okay, so this is what you should see. Then you're going to click on the title, which is the link, and that'll open up a new window for you. Oh, come on now. Sweet baby Jesus, what is happening? There we go. All right. That took longer than I wanted. All right, so when you're here, you're going to click on Net Force, and you should see this. So again, I'm going to be hopping back and forth between these two tabs. All right, so if you have this open in one tab and you have this open in another, put done in the chat. All right, thank you guys. Now, something about today is I'm going to rely heavily on your participation today, because normally in class we'd be sitting here and we'd be doing this simulation in person, and I'd be calling on specific people, and it'd be going back and forth like that. That's how we would do this in class. But since we're online, I'm going to need you guys in the chat, or you can say it out loud if you prefer that too. All right? So, first up, you should click Net Force. Scroll down a little bit. All right, and then the Net Force section says enable measurement functions by checking the boxes in the top corner. So these boxes here. So go to your simulation and check, check, check. So then it says explore the program by placing a red and blue figures on the rope and to simulate tug of war. All right, so what is the exact measurement of force that each figure can pull? So this is the tug of war simulation. You have blue team on the left and you have red team on the right. You can click and drag each person and place them anywhere on that side. It doesn't matter where you place them, but you click and drag. So if I put one here and one there, it doesn't matter where you place it on that side, but blue only goes on the left and red only goes on the right. So how you figure that out is by dragging a character up and dropping them down. It'll then tell you the force here. So the force of the little guy is 50. These two, the little guys are the same. Medium guy and big guy are different. All right? So if you drag and drop them, make sure you only go one at a time. All right, and just a little bit of a warning for how I'm gonna work through this worksheet here. I'm only gonna put in a few answers every once in a while. I may talk about them out loud because you guys are here. But what I want to avoid is people just like waiting till the end and then like screenshotting, what I have and then just copying it all down and not paying attention. So also when you rewatch the video, that way you just can't skip to the end and see everything. All right, so I want to give you guys the benefit of being here in class by speaking the correct answers to you. But if you have to rewatch it again, it'll still make sense. But I don't want people cheating and just waiting till the end and watching what's on my screen. So I may not write everything down. I will type down things that are important or you might need to see visually. But I want you guys to get the benefit of being here in class. And we'll put some answers in the chat as well. All right. If you just joined, we are in the week 4 folder and Forces in Motion part 1. And then when you get there, open this link and click next. All right, so tell me in the chat, what was the small guy? What was his force? Excellent. Small force was 50. Very good. What was the medium? What was the medium guy's force? Okay, good. Medium guy's force was 100. And then what about the large guy? Who can tell me what was the large guy's force? Thank you guys. Good work. It was 150 newtons. All right, so then which guy can pull with the most force? Should be pretty obvious. The largest dude. All right, so everybody should be done with number 1. Before I move on, does anyone need me to repeat any parts of number 1? Going once, going twice, moving on. All right, so what we're gonna do now is place 2 small blue figures against 1 medium red figure on the right and press go. So what you're gonna do over here, so you put 2 small figures on the left. Now, it does not matter where you put them. You can put them anywhere you want. It's still gonna be the same thing. Okay? It does not matter where you put them. Against 1 medium guy on the right. All right, and then hit go. So what happens when you hit go? What's the resulting motion when I hit go here? Good. They don't move. Very good. So that is the resulting motion. They do not move. All right, so then what is the sum of the forces? All right, so the sum of the forces is right here. Very good, Gianni. It is because I balance each other out. You're ahead of the game. Good work. So the sum of the forces is 0. Now, what does the word sum mean in math? What does the word sum mean in math? All right, good. Total. And how do you get a total? How do you get a total? Good. Thank you, guys. Adding together. So the sum of the forces is the addition of all the forces. All right, the sum of the forces is also sometimes called the net force. Next week, we're going to get into force body diagrams, and I'm going to be using the word net force a lot. The word net force just means the total force overall. Okay, so the net force is the same as the sum of the forces. Now, you might be asking me, or might be thinking, and I hope you're thinking that, oh, well, if you said sum, we should be adding together the forces. So why is the sum of forces 0 when you can see on the screen that each one is 100? All right, so we're going to divide this like a number line. All right, we're going to pretend that everything to the left on a number line is negative and everything to the right on a number line is positive. And when you add, all right, so remember, if negative 100 is moving in this direction, how did we get negative 100, by the way? How did we get negative 100 on that side? If you said that each little guy above was 50, how did we get negative 100? If this guy is 50, how come it's 100? That's what I'm asking. Hello, Earth to people. How did I get 100? Excellent, thank you, Gabrielle. All right, right, there's 2 of them, and each one is 50. 50 plus 50, if you put it in your calculator, don't do that, is 100. So then the forces that are on the same side are like on the same team. If you have 2 people tugging on one side of the rope, you're going to add the force that they pull with. So A on this, not A, but the blue guys on this side, you're going to add their forces together. And that's how forces work when they're applied in one direction. If you need help lifting up a table or a couch and you're moving a couch, then you're going to need 2 people to lift because you can add the force that you guys can lift with together in order to lift something heavy. So these guys on the left side are adding their forces together to pull against the right side. All right, so this is how we're going to use the math. All right, so I'm going to start with a parenthesis. All right, and again, the sum of the forces means they're going to be adding. All right, so the left, if it's moving to the left, it's going to be a negative number. Now that in science, the negative numbers don't always mean it's less than. Okay, we're going to find out when we get to some more physics later, that negative can just mean a direction. All right, so in this one, I know it's kind of weird, but negative means to the left. So you have 2 guys pulling with 50 newtons to the left. So negative 50 newtons. And then the second guy, so I'm going to add his force on the same side. Okay, so this represents the left side right here. Now for the sum of forces, I have to add the opposing force, which was to the right 100 newtons. So this is going to stay with a positive number. When you add all these forces together, you have negative 50 plus negative 50, which is negative 100. Negative 100 plus positive 100 equals 0. So this is what I mean when I say show the math. Put in parentheses what's on the left side and what's on the right side. If it helps, I'm going to put them both in parentheses here. So Over here is the left side of the equation, or the left side people pulling, and over here is the right side of where the people are pulling. So what we talked about earlier this week was a balanced force. If the overall force is 0, then I saw someone said earlier, Johnny said earlier, that because they balance each other out, when the forces are balanced, there is no motion. And that's how you know. You know these forces are balanced, and how do you know? Because there's no motion. Everybody follow so far? If you're confused or I need to re-explain something, please, please, please ask. Okay. Speak now, forever hold your peace.
What if I'm not finished?
What do you mean if you're not finished? All right, I mean, I'll give you a few more seconds. All right. If you are done with number 2, put that in the chat so I kind of have an idea of where we're at. So A and B is what is the resulting speed. All right, so look here. The resulting speed, if you look at the speed dial, is at 0. And then what is the sum of the forces? What is the net force? You can see that right here is also 0. Good. All right, if you are done with number 2, put done in the chat so I know who's done. We have 9 or 10 people in class right now. So I'm looking for at least 5 of you guys to be done so I can move on. Right now I have 2 people done. If you have questions, put it in the chat before I move on. All right, so for D, all right, are the forces balanced? All right, and you can see that right here. All right, so think of this like a scale. You have 100 force on the left, and you have 100 force on the right. Say they were pounds. If you put 100 pounds on the left of the scale and 100 pounds on the right, there we go. Let's get on to number 2 or 3. All right. I do want to say, if you are good and you're picking this up quickly, you don't have to wait for me. You can go ahead and move on ahead of me. All right, but I do want to give those who need my help and need to see it in front of them the opportunity to do so. So make sure that if you're going ahead, just kind of keep an ear open. Feel free to answer the questions when I get there, but make sure that you don't have to wait for me if you get it. Okay, so it says place 2 small blue figures on the left and 1 large figure on the right. Now, before you do this, you need to hit return. Otherwise, if you pull this guy off while you're running, it's gonna move. Okay, so make sure you hit return. All right, so I have 2 small guys on the left, 1 big guy on the right, just like the directions say. Place two small figures on the left, place two right on the right. So what you're gonna do is you're going to hit go and then observe what happens. So when you're watching this, make sure you're looking for what is the motion, what is the sum of the forces, what is the net force. All right, I'll go through this C with you, and then you should be able to answer D and E on your own. So this is just like number 2, but just a different scenario. So I'm gonna hit go, blink. All right, so you can see that it moved to the red side and red won the tug of war. Also, pay attention to the speed. It starts low, but it's increasing, it's still increasing, it's still going up, it's still going up, still going up. All right, so it was increasing all the way to the very end. So the speed is continuing to increase right up until it hits the block. So you see how the speed is still going up and it hasn't touched the block yet? So what you can say is, what was the resulting motion or speed? All right, so what happened? What happened? Put it in the chat. What happened? All right, good. Thank you, Amelia. The bigger one moved the smaller ones. All right, make sure the only thing I would change about that is add a direction. So what direction did it move in? Then what was the sum of the forces or the net force? So the sum of the forces right here. So put that for B. For the math part, again, so we're going to start with parentheses. So the forces on the left were just like the last time. So we have 50 negative. Remember, 50 negative just means to the left. That's all negative means, is to the left. Since you had 2 of them, you have to add those forces together like you told me earlier. All right, so negative 50 plus negative 50. These represent the 2 small blue guys on the left-hand side, each pulling with 50 newtons. So since it's the sum of the forces, you have to add it together. All right, so what number goes here? What is the force pulling to the right? Put it in the chat. What is the force pulling to the right? Put it in the chat, please and thank you. Again, you guys got to show me you're paying attention. Okay, close. Look back up on the top. All right, how much did the large guy pull with? All right, good, Johnny. 150. So this number needs to be 150, 150 newtons. All right, so if you do the math on this, all right, this turns into 100, or sorry, excuse me, negative 100 newtons plus 150 newtons. And that equals 50. Did I lose anybody on the math? Okay, my last class, I lost some people on the math. Did we follow on the math? All right, what's up? Again, you don't have to have exactly what I'm typing. Either one of these would work. So this would work, but I'm just showing you that it's 100 over here minus, or I'm sorry, plus 100 over here. A negative 100 plus 150 is 50, which is where this number came from. You're subtracting, you're adding the sum of the forces, but the sum of the forces on the left are negative. On the sum of the forces on the right are positive. So, like we talked about in the last one, if you have balanced forces, it is equal to 0. We had no motion. But in this one, we have motion. So this one can't be balanced. This one is unbalanced. And you know because there's motion. Or you could say that there was a net force. Any one of those would work. And then finally, what happens to the speed of the cart when one side is winning? So what do we notice about the speed? It started at 0 and it increased to here. So what should I put for E? You can speak it if you don't want to type it. It might be faster.
The speed increases.
Excellent. The speed is increasing. Very good. All right. So we should be good to move on. Do I need to repeat anything? All right. Do you need me to repeat this? Like, do I need to explain this again, or do you get it and you're just typing it down? Okay. All right, so you guys got about 10 minutes left, and I want you guys to do these last 4 on your own. I will explain 7 and 8. All right, so I want you to think about what happens when the unbalanced force, the sum of the force is not equal or unequal. when the forces are unequal, is there motion or not motion? Is what I'm looking for here. A balanced force is when the sum of the forces is what? Okay, you can look up here again if you're looking for that. And does not cause the object to blank. What happens? Is there motion, move, or not move? Okay, so I'm going to give you guys 10 minutes to finish up these. Whatever you don't finish will be homework. But if you need help, put it in the chat or shout it out and I can help you out. All right? But make sure you're working on this. Take advantage of this. And I really hope that when the class is over, you can just hit submit and be done with this. All right, so we got about 5 minutes left in class, so I just want to wrap things up. If you need any help, make sure you use this time wisely and ask me when I'm done. Or I have office hours from 11 to 11:50, so that'd be right after this class at 11 o'clock. Or from 2 to 3 p.m. Join in using my office hours code, which I will put in the chat, so you can ask me for help. It does not have to be specifically for this. It can be for anything at all. So I will answer people's questions in the order that they come in, or if I have enough people that need help on one specific item, I'll go over it with everybody. So fill in the blanks. Remember, over here, I'll kind of give you guys a hint on 7 and 8. Unbalanced forces is when the sum of all forces is what? So what would the sum of all forces be? All right. It would be anything greater than 0. So you can put not equal. And then you could also put here, cause the object to do what? When the forces are unbalanced, what happens to the motion of the object? And the opposite is true down here. A balanced forces is when the sum of all forces is equal to 0, or they're equal, and then the object does not move. Just a little hint. All right. So, and then when you're done, hit this big submit button up here, and you should be good to go. All right, if you have any questions, leave them in the chat and I'll answer them. But if you're all done, you're free to go. Or if you want to work on this on your own time, it is due tomorrow by the end of the day. All right, so if you are all set, I will see you on Monday.